Good morning, students. Today we are discussing about Friedel craft alkylation of benzene, which is very important for CBSE Grade 12 examination and JEE and NEET and all set examinations of State Board. In this, first of all, the benzene is reacts with alkyl chloride in the presence of Lewis acid like AlCl3. It can form alkyl benzene and HCl. So this is the reaction. It is the basic reaction. So here the AlCl3 can be act as a Lewis acid. Now we are going to discuss about the mechanism of this reaction also. Let's wait. Let's see the mechanism of this reaction. In this mechanism, the step 1, the generation of electrophile. The electrophile is positively charged species or it may having that vacant orbital. Now here the AlCl3, which is the Lewis acid having the vacant orbital, has to be reacted with alkyl halide and forming that AlCl4 minus and R plus. Now here it is to be called as alkyl carbocation. Alkyl carbocation. This alkyl carbocation is the electrophile in this reaction. In the second step, step 2, the whatever the electrophile is to be generated, that is alkyl carbocation, is acting on electron rich species like benzene. Here the benzene is there, which is the electron rich, has to be reacting that R plus, and it is forming the unstable sigma complex, nothing but arenium ion has to be forming. It is to be called as the sigma complex and it is to be called as arenium ion. How this sigma complex has to be formed? Let us see. Here the benzene is having 3 alternate pi bonds. Now the pi bond has to be shifted to the one of the carbon and it is forming here this is the negative charge and here the partial positive charge will be there and these are the 2 pi bonds. Now this R plus will be attacking at the negative end here. So now this R plus has to be attacking it here. Now it is the R plus has to be attacked. And now this plus is to be there. That is to be called as arenium ion. Now it is arenium ion. Now here the one of the hydrogen is also to be exist at this carbon. That carbon has to be removed as a proton. Again the resonance can be completed. Let's see the whatever this hydrogen can be left as a H plus. Now this can be formed like this R here. Now this is to be called as alkyl halide. Why this H is to be left as H plus means now the AlCl4 minus can come to near to this arenium ion. This H plus has to be attracted by this and then byproducts are formed AlCl3 and also HCl. Right? The what are the important for this one in the objective point of view means I will tell you what are the conditions of carbocation. Carbocation rearrangement can be happen depending upon the stability. What is the stability order of carbocation? You know already, I think so. That is the benzyl carbocation is to be greater than allyl carbocation is to be greater than tertiary is greater than secondary is greater than primary. So depending upon that the rearrangement can also to be happen, right? Let us see some examples of this Friedel alkylation of benzene. Let's see some examples. Here the benzene has to be reacted with CH3Cl in the presence of anhydrous AlCl3. Simply it is forming that methyl benzene, nothing but toluene, and also HCl has to be released. Let's take another example. The benzene has to be reacted with CH3, CH2, CH2Cl, nothing but chloropropane. Now what is the product has to be formed? Let's see here. If the Cl has to be released out, the whatever the carbocation is to be formed here, CH3, CH2, CH2 plus. Now it is primary carbocation. If the arrangement is possible to shift the carbocation to the secondary carbocation or tertiary carbocation, the rearrangement can be occur. Let us see here. Here the hydrogen shift has to be takes place. Now this carbon is to be the secondary carbon. Now this secondary carbocation can be formed. It's a possibility is there. So now in this case, 1,2 hydrogen shift has to be takes place. Then now it is forming CH3 bond CH plus bond CH3. Now it is the electrophile. It is the electrophile. This is not electrophile because of the rearrangement. Now what is the product is to be formed here? This is the benzene is to be attacking here the carbon CH, CH3 and CH3, isopropyl benzene. Simply we can be represent like this, right? Now you clearly understand what is the difference of rearrangement, right? Let us see one more example is there. Let us see one more example. Now it is the benzene. Let's take CH3, CH, CH3, bond CH2, Cl. Now is there a possibility of a rearrangement, right? Here there is the Cl has to be leaved, the AlCl3 in the presence of AlCl3. Here is also AlCl3, right? In the presence of AlCl3. Now it is the carbocation is to be formed. Now there is a shift. If the shift is possible, it is a primary carbocation, that is to be secondary, right? Sorry, tertiary, right? So tertiary carbocation is more stable than secondary primary carbocation. Hence, the carbocation, the tertiary carbocation has to be formed due to more stability. Now this carbocation can be act as a electrophile and it is to be bonding on the benzene, attacking on the benzene. Now it is forming like this, CH3, CH3, CH3. So these are the type of questions are very, very important in the objective point of view. Hope you understand, or if you understand well and if you like well, then we will update more videos regarding all the mechanisms of organic chemistry and important questions of all the previous year questions, one by one video, short video only we will post nearly 3 minutes or 4 minutes. This is the first video, that's why we are posting the long video like 8 minutes, nearly 8 minutes. Hope you enjoying, happy learning, have a nice day, take care, bye.